Hello and welcome to today's Black Hat webinar, What IP Data Can Tell You About VPNs, Proxies, and Signals You Might Be Missing, sponsored by IPinfo and broadcast by Black Hat. Terry Sweeney here, contributing editor with Black Hat. I'll be your moderator for today's discussion. In a nutshell, our program today is intended to be a grounded, transparent look at how IP data can support VPN and proxy detection, and also what its limits are. Our presenter today will be drawing from observed infrastructure patterns and signal analysis. So the session focus will really be on how teams can interpret and apply IP level data responsibly. On that note, I'm glad to welcome today's speaker, Ben Dowling, founder and co-CEO at IPinfo. Ben, we really appreciate you doing this. Before I hand it over to Ben, I just want to remind our audience of a couple things. If you've been here before, you know this webinar is designed to be interactive between you and the speaker. At the bottom of the screen are some buttons you can click to learn more about Ben, download some resources, and also share this webinar on social media. This is also where you'll participate in the Q&A session that takes place at the end of the presentation. You can also use the Q&A area to let us know if you're having a technical issue, and our team will do their best to help you out. Okay, I think that's it from my side. Ben, the floor is yours. Ben, you may be muted. Ben, try doing a refresh of your browser and see if that resets your audio. We'll give Ben a second just to reset his audio and ask you to stand by during this technical issue. Ben, you're back.
Hey, I'm back. Can you hear me this time?
Yes, loud and clear. The floor is yours.
Not sure what happened, but we're back and we can continue. So yeah, thanks for the intro, Terry. As you said, give an overview about IP data, focusing on our privacy data, what that is, how we put it together, and how we hear from various customers of ours on how they use it, and some best practices that we've really learned from them, and different ways to apply it, and different techniques and some insights that we take away from that. So here's the agenda. As I say, we're kind of covering our privacy data, what that means, what that includes, how we put it together, and then how our customers use it. There's a chance for Q&A at the side. So if everybody's got questions as I'm kind of going through these slides, please chuck them. I think there's a chat where you can add the questions, and we'll curate those and go over those at the end. I think we should have a bunch of time for Q&A. So I'm the co-CEO of IPinfo. At IPinfo, we do a whole bunch of different data sets, bringing context to IP addresses. So geolocation is maybe one of the data sets we're best known for. And it will tell you, given IP address, where is it in the world? We do carrier detection, so is it a mobile device or not? And then another one of our really important data sets is privacy detection. And so the focus today is going to be around that and lessons and insights from that. But we do more than that, and there's a bunch of resources at the end where you go find out more about those. I want to kick things off with a poll and just ask of the audience who's using IP data today, not anything IPinfo specific, and not even really just privacy data, but of any how important is IP-based signals and contextual data in your workflows or in what you do? And so yeah, poll for the audience. Would love them to answer this and give us some sort of insights on the mix of what the audience are using today.
Ben, you strike me as somebody who might enjoy games of chance. If you were betting on one of these answers, where would you put your chips?
Yeah, my chips would all go on A. So my guess is that a lot of the audience already use IP data extensively. That tends to be what we hear from our customers and new leads that come into that we talk to, is that generally that's where customers are. They're well aware of IP data sets and signals, and it's an important part. And they're always looking for more accurate data, more depth in the signals. But they're sort of at that point where it's already a really important signal, it's already proved its worth, and they're just looking for better data and more coverage. But yeah, interested to see. But that's what my chips are. My chips were on A.
Yeah, well, let's see where our audience is. It looks like about half of you have voted. If you haven't plugged in an answer, give us the idea of which one of these falls closest within your organization. Give this just another few seconds.
Oh, so let's look at results from 50%. So let's see. Okay, interesting. So I may have lost that bet. I shouldn't have gone all in. So it looks like we've got about 25% that use the data extensively, which is really interesting. I thought that would be the winner. 45% yes, but only for specific use cases. So that's really interesting. And so that means that yes, the IP data signals are useful, but only for probably a subset of customers' use cases. So that'll be interesting. Hopefully, throughout this webinar, we'll give you more reasons to kind of explore more IP data sets, and maybe there's some new uses for you. So that's really good. Not yet, but planning to is 16%. So that will make sense. Here to learn more about it and where it might be applied. And no plans to currently. So we'll see if we can kind of convert some of those audience members to people that might want to explore it more in the future. So yeah, super interesting poll.
Good stuff, folks.
Awesome.
Thanks for participating. Yeah,
thanks, Terry. So IP data anonymization. So I'm going to talk a lot about our data sets and what privacy detection means. Here's a simple image of some of our privacy API. This one for Apple Private Relay. And when we talk about privacy data anonymization, we're really talking about a whole bunch of different things. And there's a whole bunch of different use cases. And that's really what we're going to be kind of focusing on today is all those different things. So when we talk about privacy data anonymization, different terms for these, what are we talking about? So there's some specific technologies here, specific types of services. But fundamentally, what we mean by anonymization and privacy is that someone on the other end of this, there's an actor. If an actor would normally be on the internet, we might see their direct IP address. We can have context about that, geolocation being one of them, right? So this is an IP address based in Seattle. This is a user on a residential IP address. Anonymization or privacy service is a service that that actor can go through so that the person on the other end of that service, be it a website, be it a network login or something else, is going to see the attribution of the anonymization or privacy service. And so there are various different technologies here. There are various different motivations for using them. But that's what our data will do. We'll do attribution to those things and say, hey, this is a privacy or anonymization service. And these are the ones that we sort of include in our data sets. And so VPN is one that is commonly known, massively grown in popularity recently. I'm in Seattle and I've been seeing a whole bunch of Molvad VPN ads lately on billboards on the back of buses all over. See ExpressVPN ads on TV now, and all the stats are out there about the explosion in popularity of VPNs for all sorts of different reasons, and there's different use cases. But VPNs is sort of the bulk of our privacy data set and the bulk of the detections that we do. We do attribution to specific providers. So not only do we do detection of VPNs and we'll say, hey, this IP address is does belong to a VPN service. For about 200 of the most popular services, we'll do attribution to a specific vendor. So we'll say, hey, this IP address is a VPN exit node and does belong to Molvad VPN or NordVPN, or like I say, for 200 of the most popular services, we'll attribute it specific to those. That number 200 is consistently growing. We're adding new providers all the time and increasing the attribution coverage. We don't only detect those 200 services, and they're the ones that we just do attribution for. But I'll get more into how we kind of put this data set together and the various different approaches. But we do attribution to many more VPN IPs than we do to specific services. So even if there's a specific vendor that we don't have attribution for, the chances are we detect their IPs anyway. Proxies. So this is open, public, often web proxies, but it can be SOCKS proxies or other services. This is a much smaller part of our data set, but is included for completeness. And so if there are people that just proxy in their web traffic or something through an open relay, we'll detect that as a proxy. We jump down to Tor exit node. So Tor, the onion router is an anonymization service. We have exit node detection there as well. And again, that's kind of for completeness. Relay is how we classify a growing trend of services like Apple Private Relay. Google has something similar, and so do some other services, where these are services designed to give users privacy so that you can't see their own IP address, but they preserve geolocation. So Apple's Private Relay, how they've designed the service and architected it is they will try and map users to a pool of exit IPs that mirror the location. So the geolocation is accurate in those cases, or it's less precise, but you get the right approximate geolocation. But it's a pool of users rather than a specific user. And so you can see different types of behaviors based on this versus, say, commercial VPNs, where the geolocation will be the location of the exit node versus the user. So you may want to handle this in different ways, and I'll get more into kind of how to leverage the data and how you might want to use it. But this is a set of services that we detect and flag, and we're seeing growing popularity there, especially with sort of Apple as they roll it out to more and more devices and opt in more users by default. Hosting provider IPs are sort of straddle the world of anonymous privacy services and not. These are IP ranges where it's possible to go buy a server, lease a server. So you could think of IP ranges, a big provider like DigitalOcean, where someone could go and rent a VM, AWS, cloud providers, and then really niche vendors in specific geographies where you can just go and buy some IP space. And so we do a bunch to detect this type of IP space and label it. That doesn't mean that we've seen an anonymous service running there or evidence of that, and generally we haven't, otherwise we would have flagged it as such. But it is somewhere that you wouldn't expect to see normal legitimate user traffic. These aren't residential IPs. These generally won't have a user at the end of it at home or in an office. So there could be some automation running, some scripts or some bots, or it could be that someone's gone and bought a VM and then they're tunneling their traffic through it. And so we include this in our privacy data sets. It doesn't mean that there's a VPN or one other sort of types of these services running, but it means that there could be. And as I get more into sort of the different use cases and how to handle this, one thing we want to emphasize is there's not sort of one size fits all to treating all these as, okay, this is bad, or block these users or do different things. It can be a lot more nuanced than that, and sort of depending on what category we assign or some of the other attributes, you may want to kind of treat those differently. And so that's with host providers. And then residential proxies is one that I'll get into more detail in. This is a newer data set for us, and one that we're seeing, where our customers are seeing sort of more and more of the abuse shift to. And so with residential proxies, they can be compromised device, malware, or it can be, there's also some other ways that these residential proxy networks can get their hands on residential IP space. But with this is a genuine residential consumer IP range. So Comcast is a major provider in my region here in Seattle. And so some of the mitigations for abuse you might see on a VPN is to say, okay, this is a NordVPN exit node, we're going to handle it differently. But if it's a Comcast residential ISP, we do think it's likely to be a user at home and may mark it as safe or treat that differently. And so a lot of our customers and a lot of what we're seeing on the internet is that sort of the most sophisticated abuse is moving to these residential proxy networks because it can bypass a lot of other checks. And so these are IPs that may otherwise appear as completely legitimate consumer IP space. So Comcast IP in Seattle, where it's not associated with a VPN or any other anonymization. It's not a hosting provider range. It's not part of Tor. Without a residential proxy detection, it appears as some of the safest, most benign IP space. But we do a bunch of work to try and detect which IPs are part of which residential proxy networks, and flag those. And then there are a bunch of things that you can do with that. But that's a trend that we're seeing more and more, is a lot of abuse, fraud, and malicious behavior shifting away from VPNs and hosting provider space to residential proxies. And so we've got a solution for that with our residential proxy data. Cool. So that's kind of an overview of what services and things that we include in our privacy and anonymization data. Then there's various ways that teams can use this data. So I mentioned at high level some various forms of abuse and risk. There's all sorts of different use cases for this. So e-commerce. One thing there is obviously payments risk and fraud. Maybe that the abuse is shifting from So I guess the most basic sort of e-commerce fraud check might be does the credit card country match the user's IP address location? And obviously and your geolocation data can be used there. Maybe that you're seeing someone with a stolen US credit card, and maybe they're based in Brazil, doing a purchase online. And if the credit card country doesn't match the user's country, you could flag it for fraud, which may mean blocking it, may mean manual investigation, could mean all sorts of different things. But you want to kind of mitigate that. One way to clearly bypass that, once you've got the geolocation checks, is to say, well, great, I'll go through a VPN exit node in the US and go get ExpressVPN, NordVPN, any one of the other major commercial VPN providers. And at that point, you would pass that VPN check, that country-based check. It could be a stolen US credit card, and it's a US IP address. And so then for the fraud that was previously blocked with a VPN would bypass that check, and then the fraud event could happen. And so that's one example. And obviously, once you have our VPN data, the next evolution of that tends to be residential proxies. And so we can see fraud shift there. But that's a really common use case of something to do with this data is payments fraud and risk online and checks with that. Streaming is geo restrictions, and so lots of online content is licensed per region, and so the major streaming providers, Netflix and similar, you have different catalogs available in different countries. And this is a really common use case for VPNs, is to say, well, hey, maybe I want to get a cheaper version of Netflix and set up a VPN that goes to a country where Netflix is cheaper and sign up there. They want to be able to go and access Netflix in a different country where there's more content. Maybe I want to go and access something that's streaming only to the US and outside of the US. And so this is a really common use case for VPNs. For the world of risk and fraud and malicious behavior, maybe this is something that is less interesting. These users might, there are people that want to be able to go and stream content from certain sites that probably aren't the same set of users that are committing credit card fraud and other things. But for those streaming sites, this sort of enforcement is really important. And so it's an important use case. But I think that talks to the fact that there are lots of different use cases for those users, that the actors that are actually using the VPNs, the resident proxies, and some of those are malicious and may want to commit fraud. Some of them could be completely benign from the perspective of, say, a payment site. The user may have a VPN because they want to go look at Netflix in a different country. And so sort of how you leverage the data and the enforcement you want to do it can really influence that. So security is obviously another one, and is probably the most important for this audience and people associated with Black Hat, and a big segment of our customers in the cybersecurity space. And so there are all sorts of different things here in terms of writing rules for enforcement or investigations. But it could be that someone's trying to failed login attempts to the corporate network, and that may not match the location of the employees. And so similarly with the payments use case, it's you could have, say, to our corporate network, we only want to allow logins from the US, and we can, all our employees are based in the US, so we can filter any non-US traffic. One way to bypass that would be to use VPNs. And then, you can VPN into the US and then attack the corporate network. And so obviously one mitigation for that is then VPN detection. But again, it may be that it's totally legitimate for customers for employees to use VPNs. And so you might have a more complex set of rules and enforcements. But obviously it's a really important use case. And then bot defense. This is one of, I think, the big initial drivers for residential proxies is scraping and crawling and things like that. And obviously a lot of the hosting detection, is space where it's very easy to run software and scripts and bots. And so these are 4 use cases that we see that are very common with our data. One thing that we try and do is provide factual data about these spaces, about these categories. And so we're constantly finding new customers, finding new innovative ways to use our data. And so this is just a subset. These are some of the most common ones that we see. But there's all sorts of interesting ways that people can leverage our data to do various different enforcement or mitigation of various risks. I think a really, really important point to hammer home here is that these lists aren't static and the data isn't static. And so these things can be pretty volatile. And so as we look across all of our data, and like I mentioned, we don't just do anonymization data, we do geolocation and carrier detection, a whole bunch of different things. But when we look across the attributes in our data sets, we see anything from 7 to 56% of the data attributes change every month. And so on the sort of the more stable side of that, we're looking at location, and then sort of the most volatile data sets tend to be these privacy type ones and certain residential proxy data. And so it's really important when you're thinking about this data, not just to get a vendor with good quality data the timeliness of the data is also really critical as well. It's one thing to be able to say, yes, we've detected a VPN exit node, but maybe that's already been a VPN exit node for a week, and so there's that window where whatever you're trying to mitigate can get through. And then on the flip side as well, IP addresses rotate in and out of residential proxy networks, and so if we're saying, hey, we've seen this IP address of residential proxy network, but it turned out that actually got rotated out of that pool a week ago, then maybe that window for a bunch of false positives. So the timeliness of the data is really important. And I think the amount of volatility that we see in the data is really important too. So making sure that your data provider has fresh, updated data and is delivered to you quickly as well is really important. Cool. So that's sort of an overview of the different technologies that we detect, various different use cases, the importance of fresh data and timeliness. And so now I'm going to talk a little bit about how we source and validate our IP data. There's a lot that goes into it. We try and encapsulate that as much as possible and just create a clean, easy-to-use data set for our customers so they don't need to get into the weeds and understand sort of all the different nuances. But it's important for us to be transparent about how we put it together so that you kind of build trust on the quality of our data. But this is sort of in the weeds now on how we put it together. A lot of this complexity doesn't get exposed in our data and our product. You can kind of just go take our data and use it. But I want to talk through some of the stuff that we do to make sure our data is really, really good. And so this diagram kind of applies across all of our different data sets. And when we put our data together, one thing that we think about is how to kind of deeply understand the internet broadly. And so we have different data sets: geolocation, carrier detection, privacy detection. And for each of our data sets, there are a bunch of techniques and tools we use that are specific to that data set. But one thing that we consistently find is that there are a bunch of general data sets and general approaches that improve the quality across all of our data. And so when we can understand what IP space is residential really well, that kind of helps us, or that helps also with the problem of detecting hosting providers, because hosting providers are where there is not residential space. And so there's a whole bunch of common data sets, techniques, and tools that we use to just build up our context understanding of the internet that feeds into many of our different data sets. The ProbeNet is something that we built out. We're now at 1,000 points of presence. We do a weekly internet census that includes ping measurements, trace route measurements. That feeds primarily into our geolocation data set. It gives us a whole bunch of constraints where we can be really sure exactly where IP addresses are. There's a bunch of ways we leverage that data to feed into hosting detection as well. It helps a lot there. We do a bunch of various different port scanning and handshakes and things that help us detect VPN entry nodes. And so the probe network is a really big asset that we've built up that we're constantly expanding. We recently crossed 1,000 points of presence. We're rapidly expanding this, and so adding tens of servers every month. I think we added 50 in a recent month, which was a record. And so this is something that we continue to focus on that improves geolocation data, privacy data, and a bunch of other data sets as well. And not only are we building out the scale of that, so adding more and more servers, we constantly improve the capabilities of the probe network as well. And so the data that we're actually collecting, the pace and frequency at which we collect the data, and the ways in which we leverage it. So that's a really critical one. And so we do VPN handshake and things from that as well that mean that we can detect IP addresses in the wild that are running VPN software. Another thing we really look at is where we see VPN-like behavior. So we ingest a whole bunch of device data, some of it our own, some of it from third parties, and we look for VPN-like patterns that we can see from IP addresses. And so where do we see a bunch of activity around the globe on certain IP addresses? That looks like VPN-like behavior, looks like outliers compared to other IP addresses. And so that feeds into the pipeline as well. One thing that we do that's really critical, this applies to privacy data and residential proxy networks, is we have accounts on most of the major providers. And so this is how we do attribution. We build out a lot of infrastructure to actually connect through the VPNs and track the exit nodes, that try and map the full set of exit nodes for each entry node. And this is a really big project for us. It can be cat and mouse sometimes with various VPN providers. But we've got really good at this, and we've got really good at scaling them out. And so, for our attribution to providers, this is something we've actually observed, right? We've connected through NordVPN, that's sort of fact-based data there. That's not probabilistic. That's something that we've actually observed, this IP on that provider. And so that's a really critical piece of data. but you're always doing research. We've got a research team now that's growing. We've actually got 5 interns this summer doing really great work, a bunch of PhDs doing a bunch of work. The focus is, again, across all of our data sets. So we're doing some work on carrier detection, geolocation, there's some privacy-related work. But one thing we see, like I say, is that as we focus on trying to understand the internet broadly, that any improvements we make in one area tends to have a positive reinforcement in other areas as well. And then there's a bunch of public data as well. So there's all these various things that we layer on top. Some of that's data collection, some of it's algorithms. And so how do we take some of the signals from some of these pipelines, use that to reinforce some of the other ones? And there's just a whole bunch of public data. So I mentioned we have public proxies and open relays, Tor exit nodes. We have a bunch of IP registration data from Whois, and we look for what are the signals we can take from some of those other ones, open IPs or exit nodes that we've crawled through, and map that back to IP registration data. Can we find vendor names and various different things in there? And so it's a big process, but at the end of it, we come up with a bunch of IPs and ranges that we've got attribution for, or suspect as IP address, suspect as different anonymization services in the different data points there, and then bundle up into a data set. To summarize all of that, some kind of key signals that are used in our detection: public lists, direct server scans from a probe network, VPN handshakes and responses, open ports, suspicious device activity, Whois, that's IP registration data associated with providers, and that's the privacy data set, and then the hosting signals that we use as a separate, that's included in the privacy data set, but a separate pipeline for detecting those hosting providers. So we look at signals like hosted domains, pingability, various ASN characteristics, and a bunch of port scan data around that to get really accurate detection of what IP ranges we think belong to hosting providers. And then all of that culminates in our privacy data set. And so here's the schema. This is an overview of what the output of that is. And so this is our extended privacy data set. This is available as a data download, and I'm going to do a poll next to ask how people would generally like their IP data delivered. We also make this available via an API, available via Snowflake Marketplace. I think we're in the Google Cloud Marketplace now. One thing we're really interested in is making it easier for our customers to ingest our data and leverage our data. So we have integrations with various different platforms and services as well. And one thing we like to do is get feedback from our customers of where we're using our data, and is there anything we do to remove the friction. And so we like to create really great data, but we like to make it really easy to use as well. And so this is an overview of schema for data download, but available in lots of other places as well. So these are the fields. It's kind of things that I've covered, right? A flag for hosting, proxy relay, Tor VPN, the service name for the attribution to the actual vendor, and then the first scene and last scene. So these are the dates. And so these can be really critical for kind of tuning false positives and false negatives, or how you want to act on something. If it's a VPN, but we haven't seen it for a week, we'll include that data point. So you may want to treat it differently from, say, a VPN that we've seen that day, or maybe if it's a VPN from the last month, you might want to act on it differently from a VPN seen more recently. And so those tend to be really critical data points for tuning the behavior based on what we observe. We have a confidence certainty level. So, very certain is, we've kind of called this IP, we've seen it, we've directly observed it, and we've seen it recently, down to low level confidence, where in those cases, we've probably seen, we have high confidence IPs that look to be associated with this IP, but we haven't seen direct evidence from it. And so that might be that, there's a cluster of VPN IPs on the same net block. We may not have observed the actual behavior on this IP, but we have seen a bunch of other ones nearby, and various different permutations of that. Coverage, so again, this is how much we've directly seen. And then census flags based on, this is measurement data from a probe network, device activity, inferred VPN config, and Whois, tied some of those different data points we've seen. And so expose these data points so that then customers can go take these and tune what they want to do based on our level of confidence or things that we've seen. And so for some use cases, this is too much detail, and it doesn't matter. If you just want to kind of throw up a capture, if something may be VPN-like, you don't need to kind of get into the weeds on this. If you're building out a risk model, your own risk scoring based on top of our data, all these flags can be really useful for fine-tuning that. And so we try and include as much of these data points as possible to make that really helpful. Then on top of our extended privacy data, we also have a residential proxy data. I talked about that a bit. That isn't included in this schema here. This one is the VPN and the other services. Residential proxy data looks very similar to this, has an IP address, has a provider, names or attribution to specific residential proxy network that we've discovered it on, has a first and lasting date, and has some other attribution fields. And I think we'll get a schema of that up shortly, and so I can show that. And so next up a poll. So like I say, that's the schema for for one of our data downloads. It's also available in the API. We did the poll earlier asking, are people already using IP data? One thing I'm really interested in is how people can, people that do use IP data, how they're consuming it, and maybe we broaden the question out to not just IP address data, because I know there's some attendees that aren't using IP data. But for any third-party data that you're using, that you're ingesting, I guess whether it's threat feeds or IP contextual data, maybe domain data or anything else that you might be using, what is the best way that you prefer to ingest it? One thing that we see more and more is customers like do it in multiple ways. So maybe that they download a data feed for, that they might want to ingest into their rule engine, but then they also want an API that a different team can maybe go and do some research on or look things up. So we're seeing more and more that customers want to consume data in multiple ways. So I think with this poll, you can kind of select all that apply. So if that, but it'd be great to know what ways you're currently doing it today, or if this is something that you want to do in the future, what are ways in which you would like to be able to ingest data?
Boy, this is no more just a bunch of homogeneous tools. This is a bunch of different ways to get at this issue, isn't it? Yeah,
absolutely. And like I mentioned, one thing that we like to do is try and understand, we like to create great data, but then a consistent pattern we've seen is customers then have to go and fight a whole bunch of friction or jump through a bunch of hoops to actually get value from that data. And so, that might be they have to go and transform it, and then they have to go and change the format, and they have to upload it somewhere, and they have to go and maybe write their own integration to a different tool, and then they go and integrate it into that tool. And for when there are customers with super niche tools or custom workflows, that's something that they may be accustomed to do. But when we've got big segments of our customers all jumping through those same hoops, one thing we like to say is, well, how do we go make that easier for that whole set of customers, right? Can we go build an integration for a tool? Can we deliver our data in a better way? And so it's something we're always listening out for is, what is it once we deliver our data that you have to go do to get value out of it, and how do we kind of reduce those number of steps?
Well, let's see where our audience weighed in.
So let's see. I'm not going to make a bet this time because obviously I lost all my chips on the last one. So let's see how we do on this one. Oh, I skipped straight past it. Interesting. So almost 65% API, and so we offer many different data downloads and different ways to access our data today. And API was where we started, so that was the first way that we ever had to deliver data. We used to be an API only company. Our API is still, I would say, probably the most popular way that people access our data. So these poll results kind of line up with that. We do over 100 billion. I can't even remember the actual number now. We do over 100 billion API requests a month. We have a rock solid, very stable, low latency API. Almost all of our data is available through the API. There's some that are sort of enterprise only, some of the newest bleeding edge data. But our goal is that all data over time is available through the API. So it's a great way for people to kind of consume our data. Data downloads comes in next. Which again sort of matches what we see with our customers, right? Most customers use our API. The second biggest segment by far is data downloads, and so we offered our API initially, and then there were a bunch of use cases and a bunch of customers where that wasn't a fit, and so started offering our data via data download, and that's now a significant you have a significant number of customers that also do that and do data downloads. So Google Cloud BigQuery at 11%, Snowflake at 0%. That's really interesting. So Snowflake Data Marketplace has been an important integration for us, and that's helped save for a bunch of customers that were taking our data and loading it into Snowflake. The Snowflake Marketplace is a way to eliminate a whole bunch of friction there. But none of these attendees use Snowflake, so that's an interesting data point. Many more in BigQuery. We use BigQuery internally. We're a Google Cloud shop, and BigQuery's a big part of how we put this data together and how we leverage it. So it's great to see people using BigQuery. Security and log enrichment tools, Splunk, Multigo, Copilot. So we've got integration with all those. That's great. People throw in the questions of specific if there are specific tools or integrations that we don't have where we use our data. If you can leave a comment or shoot us an email after, and that we've got a roadmap there for adding more integrations, and can prioritize those based on where our customer uses them. But Splunk, Multigo, and Copilot are things that we have integrations today. It's great to see 50% of attendees leveraging those, and then 8.2% other. So that's a really interesting poll.
Yeah. Ben, just want to contribute a comment from one of our audience members, David, who's saying that, that he believes that maybe the poll is reflecting the current state of affairs as opposed to, say, 6 or 18 months from now. Does that align with your perspective?
Yeah, I think that's a really great point. And I think that one thing that we often find customers delighted when we kind of say, well, we want to help you solve this problem, right? I think lots of customers are kind of used to just getting a CSV file from a vendor and then having to jump through those hoops themselves, and not having the perspective that, like, hey, we may have hundreds of customers jumping through those same hoops, those same points of friction. It makes sense for us to kind of make this easier for everybody, right? And so I think it's a really valid point, right? Is a lot of people that buy data may have to jump through those hoops and are used to jumping through those hoops. And probably using data in platforms that make sense today. It'd be very interesting, I think, to see how this evolves over time. I think we see that in our data right customer. We see more and more customers shifting to Snowflake, Google Cloud, and these other cloud platforms. It's hard for us to know how much of that is a shift because we're kind of expanding into those products versus customers moving to them as well. But yeah, I think it'd be interesting to see how the trend changes over time.
Great stuff. Thanks to our audience members. Thanks for participating.
Yeah, thank you. Cool. So I'm going to jump in a bit more to residential proxies. So I kind of given the overview of our privacy and anonymization schema that is focused on primarily VPN. So there are other data points in there that are associated, but residential proxies is something that we are as a newer data set for us. We've offered the privacy data set for a few years now. Residential proxies, I think we launched around a year ago. And we're seeing great adoption from it. Our customers have seen great results from it. I talked a little bit about that sort of evolution of, I guess, some of the sophistication of abuse and bad actors, where to bypass a simple geolocation rule, a VPN will get you around it. That credit card use case where it's, say, a bad actor in Brazil and a stolen US credit card, a simple geolocation check would trip that up. Then you can move to VPNs. You can buy lots of free VPNs or buy a $5 a month VPN service, and suddenly you've got a bunch of US IPs and you can bypass those checks. And then the trend that we see is then switching to residential proxy networks. These tend to be more niche. They tend to be more expensive. They often charge per gigabyte, but they can bypass a lot of the checks that may exist. And so, a lot of our customers see more and more of the abuse that's getting through is coming from residential proxy networks and bypassing those checks, because for all intents and purposes, it looks like a completely legitimate IP address. It may have a good reputation, it bypasses all these rules. And so this detection is becoming increasingly important. And this isn't including our current privacy data set today. So this is a separate data set. I'm going to talk a little bit about that. But you can see here's basically the schema, right? And so here we'll include the IP address, the date that we've last seen it, the percentage of days seen, and then the service name. So the percentage of days seen tends to be pretty important here, because the behavior of residential proxies tends to be different from VPNs and other services. While the data moves around and things change, and that's obviously why we have the last seen date and these other attributes for VPNs, residential proxy services are much, much more volatile. And that's partly because of how they source their IPs and various different things. But the residential proxies tend to be much more adversarial and are in many ways somewhat more designed to get around these checks. And so there's a concentration of malicious behavior and bad actors there. They are also generally these IPs are actually shared with the legitimate users. And so sometimes residential proxy networks can be built up from sort of a peer-to-peer. It may be come install a free VPN and your IP will be shared. Sometimes it could be infected devices or malware that's sort of hijacking a user's PC. And so there's all sorts of various ways that these IPs can become part of residential proxy networks. But generally, that is is an actual legitimate residential IP that is shared with an actual household or an actual user, and that could be your actual legitimate user. We did some work with a supermarket in the UK that was seeing some abuse with residential proxy networks, and obviously they'd be very sensitive because those residential IP users, not the ones in the residential proxy, the people that are actually at home were likely online customers of that supermarket as well. And so false positives became an issue there. And just sort of how you handle these is really, really important. And so that percentage days seen is, we offer various different cuts of this data. So we offer 7-day, 30-day, and 90-day cuts of the data. So looking back over all the activity we've seen over those time periods, the percentage days seen is the percentage of days, and we're continuously crawling and tracking this, but the percentage of days where we've seen this IP address as part of that residential proxy network. And so obviously this gives you some sort of stability indicator. In the example here, 71% of the days that we've been tracking this IP on a residential proxy network, it's appeared there. The other 29%, it was not. And so that, you may want to tune sort of your what your action is based on that. Because obviously the more activities on the network, the less likely there's going to be a false positive or some sort of negative consequence of the blocking. So that's a really important data point that's been really helpful. And so our residential proxy data today, I say 7 to 9 days of history, currently 87 different residential proxy networks, and similar to the techniques we use with VPN providers we use with residential proxy networks, we do attribution to the actual network. And I got some stats on the number of IPs. Here we go. So 47 million IPs tracked over 90 days. That number is continually growing as we improve our collection. So the actual calling and stuff, we do increase the frequency and the rates of that. And then we're bringing on more and more providers. And so we're out searching for as many different providers as we can find and onboard them, and then we'll do attribution back to them. So the reality is that things change daily. I talked about the volatility of residential proxy networks, and there's all sorts of reasons for that. But sort of how you handle that is really important. We see more and more, our customers are seeing more and more abuse and bad behavior shifting off VPNs onto residential proxy networks. And even if that isn't actual behavior shifting, that's kind of where they're seeing more and more of the abuse that's getting through, it can be attributed to. So not every VPN is the same. I've talked a little bit about different remediation strategies and different things, but we include these data points so that our customers can treat them differently. And so the example here is on the left. We've got I think it's an Apple private relay. And so this is one where geolocation is somewhat accurate. So it's unlikely to be used to bypass geolocation restrictions. It could be an employee using their phone. So maybe they actually do want to log into their work, and that's totally fine. Versus a NordVPN example here with a bunch of different data points. I think a really key point is neither one of these is necessarily malicious. But we don't make a determination on that. We have customers in all sorts of different industries with all sorts of different risk profiles, and so that could be, I covered some of the use cases before, but could be one to one of our customers, risk might be is likely to leave a spammy comment on a forum, and then a different one could be is committing tens of thousands of dollars of credit card fraud. And so the risk profiles can be very different. Where that risk and abuse is coming from can be very different. And so we aim to provide as many different data points that help our customers come up with their own sort of set of rules or risk profile and treat them differently. And so what I flag here is that the treating is VPN as true as to go and act on that. May make sense depending on the use case. Yeah, if it is, okay, we think that we see a lot of forum spam coming from VPNs. Maybe we want to throw up a capture if there's a VPN flag, or do something different where there's an easy way for the customer kind of go remediate it. But when there are sort of firmer actions, so you're blocking a user from even being able to log into the employee portal or different things, you want to get more into the nuance of some of the other fields and treat those differently. It's just really saying the same thing, right? Do not treat everything the same. That there's it can make sense in different cases if what you're doing is really, really easy. Otherwise, it may not. And so kind of don't ignore those signals. I think a really important point with residential proxies, with VPNs at least, there's often a way for a user to remediate that. So even if there's a false positive, so even if we're saying this IP address is NordVPN or there's some data there, and the user has a VPN turned on. So false positive in the sense of if the user isn't intending to be malicious or isn't intending to bypass geo restrictions, say there's a user that has a VPN turned on, they go to your website and they're blocked because the VPN's on, but they were a legitimate user that actually wanted to perform that action. And so if that's the case, the user can very often just turn their VPN off. And so, and then get on with the task at hand, and so they haven't been blocked. And so, for say, you want to restrict employee logins to, there's a policy where employees can't log in if the VPN is turned on. You can say, well, actually, you can't log in. We detected your VPN's turned on. Please turn it off to log in. They can turn it off and log in and carry on with their day. With residential proxies, that tends to not be the case. We're flagging, hey, here's a residential IP. That we have seen and observed as being part of a residential proxy network. If you've got an employee where that's the case, and then they try and log in and they're blocked, they generally won't have a way to remediate that. They can't change their IP, they're stuck, and then that can lead to a support escalation or to lost business in the e-commerce case. And so that tends to be something that needs to be handled a bit more sensitively and with different different ways that need to be baked into that flow to allow the user to kind of get to the action in the case that it's a legitimate actor. Cool. So key takeaways and recommendations here. Use privacy flags in risk models not alone. So like I say, there are some use cases where just a simple flag makes sense, but when you're when the action isn't high consequence, like I say, maybe you want to use this to then go and show a capture, or you want to use it to add some friction, or you want to use it to flag something for manual review, or for a different pathway. In that case, a very simple use case that can make total sense. But if you're seeing a lot of abuse or different things, we want to provide the data points that go and help you fight that, but it shouldn't be kind of used alone. And like I say, you want to go build a risk model or a complex set of rules that are on top of that. Data frequency is really important. I think we talked about the percentage of changes, and it was 7 to 56%, I think. And as we sort of get into some of these privacy flags and certainly residential proxy, that's where we see the most volatility, and include data points that will help give you a sense of that. So the percentage days seen, the first and last seen dates, so that we kind of expose some of the signals so you can kind of get the sense of the volatility of the data. But I think a key thing to note is that these things change really frequently. All of our data sets we make available as daily, weekly, or update refresh frequency. We can push it to an S3 bucket or to storage. You can access it via API to make sure you get the freshest data. But I think certainly when looking at the privacy-related data and mitigations using that, the refresh frequency and sort of understanding the volatility of data is really important. And that's both on sort of aging out old data and also making sure that we're kind of detecting it as quickly as possible. And so if you know that sort of all your abuse or all your issues are coming from VPNs or residential proxies, you want to make sure you've got the freshest data and that's detected as soon as possible, rather than saying a week later when you've got data saying, okay, yes, we can now see that would have been attributed to a VPN provider, but we didn't have the data at the time or it wasn't fresh enough. And so last percent seen days is really critical in the proxy detection, and there's last and first seen dates in VPN data. And then you can combine this with other signals, right? And so the focus today has been around our privacy data, residential proxy data. That's one piece of context. At IPinfo, we offer geolocation, carrier detection, a whole bunch of other data points. We've got lots more data points in our roadmap that we'll be building and shipping soon. Our sort of goal is to be able to create as rich context and as the depth of data as possible that kind of helps with all these types of use cases. Consistent pattern we've seen is that when we kind of create new signals for our customers, they're able to kind of do better than any of these signals alone. And so I keep going about the Brazil IP and US credit card example, but I think that's a really great one where you can kind of build up that richer profile. If it was a VPN alone, that gives you some signal, but as many different data points as possible can be really, really useful. So talking about our data points, I think to re-emphasize it, I touched on this a little bit, but it can't tell you what the actual user's intention is. There are all sorts of legitimate use cases and of VPNs, even of residential proxies, of hosting ranges. And so, I think I talked about the employee use case. It could be that an employee had a VPN turned on for many different reasons, but then they actually want to go log into the corporate network. That doesn't mean that someone's trying to hack you or that there's some abuse happening. It could just be a legitimate employee that wants to that happens to have a VPN turned on to log in. And so the intention isn't clear there. I think that's really important to keep in mind when trying to build out some sort of rules or different things around this. Is you're not necessarily flagging all abuse for this, that you might capture a bunch of abuse, you might catch a bunch of legitimate usage or other things, and make sure there's kind of ways to remediate that. One thing that our data really does do is kind of give you the evidence of what we've seen on IP address. So like I said, again, I want to emphasize is, we're not kind of giving a risk profile. We're not saying, hey, this is bad because we don't know what the intention is. We also don't know what a risk is for our customers. There's a whole different set of risks and different things that they're looking for. But we can kind of give you the evidence and the context points and the data points to kind of help you make a more informed decision and build a profile and understanding of what might be happening and then make better decisions. Cool. So that's it. That's the overview of our data, of how to deal with it. We will be at Black Hat. I'm very excited for Black Hat. We have a booth 5924. You can learn more about our data on our website, IPinfo.io/data. I think we've got a bunch of resources and other things here that I think are also available on your screen somewhere. So come check us out at Black Hat. Reach out to us. I would love to hear more from you.
Ben, great stuff. You really covered the waterfront well, and it definitely connected with our audience. Great job. We have a ton of questions. I'm not sure if we'll be able to address all of them, but again, just a reminder, if you've got something else to get in front of Ben, just use that Q&A box at the bottom of the screen. We'll also be sharing all of your questions with Ben after we go offline, so he may be able to respond to you offline as well. An embarrassment of riches here, Ben. So let's start with a question from Nia. Do you expose or provide a fraud risk score?
We do not. So yeah, that's a good question, and that's something that we hear from customers a lot. What we try and do is create the data points that either allow our customers to go and create that sort of risk score themselves, we've got some customers, very sophisticated customers that you're doing a whole bunch of scoring and modeling and AI stuff that's very cool and can kind of go and use our data points to help either build that in the first place or refine that. We don't do that ourselves because like I said, one thing that we do is we have customers in all sorts of different industries with all sorts of different risk profiles. And so we've got a bunch of data points that can kind of hint at that or describe that. But the risk for our customers is defined very differently for different customers. Like I say, it could be, okay, there's someone's going to leave a spam comment on our forum. It could be, a state actor is trying to take down our network. It could be, an employee's violated a policy. And so it's very difficult to kind of wrap all of that up into a risk score that makes sense for all those different things. What we try and do is understand from our customers, feedback from our customers, or how we kind of think about it internally is like, what are the different things that our customers do want to go do with our data? So all of those use cases and more. And what are the data points that would be useful for either going and writing a set of rules around that or building a risk model on that and making those data points available. And we try and make sure that all of our data points are backed by evidence and observations and that they're facts. And so we try and say, well, look, we're not saying this may be a residential proxy IP. We're saying, here's the date that we observed it. Here's the network that we saw it on. Here, and so we try and create a collection of facts that can then go and be used in various different environments for various different things. And so some of that could be risk, some of that could be all sorts of other things. We kind of give you the ingredients that we'd either let you go and build that risk score directly or bypass a risk altogether and just go and take the action that you actually want to take, right? That is like, hey, let's have a very clear policy where employees can't log in via VPNs, or if we think that this is something where we see spam things, we may flag it for review or take action in a different way. And so we try and offer the factual data points that could feed into that then allow those actions to be go and taken.
Thanks for that, Ben. Another great question from Nia. Do you have integration with Splunk? For example, if I want Splunk to flag anonymous VPN IPs, can Splunk use your data? Ben, I'm going to ask you just to expand this out to address the other integrations that IPinfo also has in addition to Splunk or others.
Yeah, absolutely. So we do have a Splunk integration. And it will do exactly what was just asked there. We actually are doing a whole bunch of work on a big improvement, a big set of updates to Splunk. So anybody that's currently using Splunk, we would love to get your feedback and we can get early access to the new version we're working on, and we'd love to get kind of more feedback on ways we can make that better, more performant, more of our data. So a bunch of active improvements going on to our Splunk integration today, but we've already got a great Splunk integration used by lots of customers. So that's something we already have. We also, have integrations with a whole bunch of platforms, right? So Altigo as mentioned, Microsoft Security Copilot. We're interested in building integrations and many, many more platforms, right? Any gaps that we may have that we want to go and build that more. And so we have a roadmap today for improving the existing integrations, building new integrations. So we'd love to hear from any customers or potential customers on where would you be deploying our data to or using it to. There may already be integration that we built. There's also many third-party integrations that our customers or your people have built that can leverage our data in different platforms. But that's a priority for us, is how do we kind of eliminate that friction of where to go use our data. And so I'd love to hear from people about where they would like to use our data. If there's an integration already, which there could well be. If there's not, that's something that we can go and build and work with that customer to make sure it's excellent.
Abinet from our audience is asking about the increasing use of IPv6 and the trillion addresses that it adds to the already enormous pool. Ben, can you address some of the challenges that will come in terms of generating intelligence on this gigantic reservoir now of IP addresses?
Yeah, totally. So, all of our data sets, are IP, family agnostic, right? So V4 and V6, our geolocation data, privacy data, all that we deal with V4 and V6. And I talked about our probe network, right? So that is one of our main data collection sources, and we do the sort of internet census that we do weekly, scanning, pinging, measuring the internet. We do that for V6 as well. Obviously, for V4, we can exhaustively do the full IPv4 space very easily. I think it's well under a day now, and then we do a bunch of top-ups and other collections as well. For V6, we have a V6 hit list, so obviously we can't measure trillions and trillions of IP addresses. Most of that space is inactive and unused, though, right? And so we use a bunch of public hit lists. We do our own hit list generation internally. So we look at what are IPv6 addresses that people are looking up for our API, what are other signals we get about an active IPv space. We look at BGP data and a whole bunch of other things, and then we try and exhaustively measure the V6 space as well, right? Using a bunch of clever techniques and a bunch of different things. And so we've got good data there. One thing we see is that a lot of the abuse that customers are seeing is still IPv4. And so a lot of the abuse that they're seeing is coming from VPNs and residential proxies and things in V4 space. We've got V6 data, but to date, not a lot of stuff is seen there. We see some stuff with scraping and things in V6. It's much easier to get around IP rate limits and things when you've got a whole bunch of V6 space. But a lot of the sort of really malicious stuff and bad actors, we've not been hearing has been on V6 today. But our data is ready. We do a bunch of stuff on V6 and we'll continue to.
Great stuff. Ben, close us out with some thoughts on what's been hard about getting your data to a level where you're confident in the coverage. Paul from our audience is also asking what methods could be used to compare providers. If you can keep it brief, that'd be great.
Yeah, absolutely. So it's always working on improving our data, right? So data quality is your paramount importance to us. So we talked about some of the other things of we like to remove the friction on how easy it is to use our data. We like depth of data, right? So adding new fields and new context to our customers can kind of get a richer experience and understanding of IP address. Those two things are really important, but I think the most important thing for us is always data quality, right? If the data isn't high quality, it kind of undermines the whole value of it. And as we can kind of improve quality, it improves outcomes for our customers. So data quality is super important. It's an ongoing thing. Our data is definitely not perfect. We're always working on improving it and have a big team dedicated to that. We do a bunch of stuff to benchmark it internally with feedback from customers through their evaluation, by looking at competitive data and making comparisons, by a whole data team that's basically working on this. The sense we get of progress is generally comes from customer feedback, right? They're the ones actually on the front lines, seeing the abuse, seeing the risk, and kind of giving us the feedback that we're able to block more, that are seeing better outcomes, and then always looking to improve it and get more feedback from them. So I think that answers it, right? This is something that we care deeply about, something that we're constantly measuring internally, collecting feedback, and so we're always striving to get better.
Well, that is a great place for us to stop. Ben Dowling, thank you so much. Black Hat, appreciate your time and expertise on making smarter use of IPinfo and improving security in the process. Thank you so much.
Awesome. Thanks, Terry.
Thank you as well to our sponsor, IPinfo, as well as everyone in the audience. As usual, you guys rock with your great questions and appreciate the extra push in the polls we rolled out to you today. Thank you all. Sometime in the next 24 hours, you'll be receiving a personalized follow-up email that'll have a link and details to today's presentation on demand. You're welcome to share this with colleagues and peers who couldn't have been part of today's live event. Now for the boilerplate, this webinar is copyright 2025 by Informa TechTarget. Presentation materials are owned by, copyrighted by Black Hat and IPinfo. Individual speakers solely responsible for their content and opinions. On behalf of our guests, IPinfo and the Black Hat team, Terry Sweeney here. Thanks for joining us for this session. We'll see you next time.